going to show two examples of solving logarithmic equations. So first, let's just look at the differences between these, because both of them have different types of process on how to solve. In the first one, we have logs. Everything is a logarithm. So when you have an equation like that, what you're going to do is use an equivalence property of logarithms, that if we have log base b of x is equal to log base b of some other argument of y, to make that equation true, then the x and y have to be the same. You have to have the same arguments if you have the same base of the logs. Now on this one, we have logs on one side of the equation, but there's also a number, and that's going to be a different process, and I'll show you how to do that on the second example. Okay, so let's get started. Here I'm looking at this. I have everything is a logarithm. Okay, so I'm going to rewrite my equation so that I have just one single log on each side of the equation. Okay, using the property of logs, I have addition here, so I can rewrite that as a multiplication problem inside the argument. All right, so that's ln of 10. And then I'm just going to simplify that a little bit here on the left side. So I would have ln of x squared plus 3x is equal to ln of 10. In order to make that equation true, these arguments, the thing I'm taking the log of, have to be the same. So that's the equivalence property. So using that, I would get x squared plus 3x is equal to 10. And then this is a quadratic equation, so I would set it equal to 0. And then just go ahead and factor and solve for x. Let's see, x plus 5, x minus 2. And then using the zero product property, I would get x equals negative 5. And then x equals 2 from here. Now, it's really important, our final step here is always to check. With logarithms, the final argument needs to be positive, and so often there's going to be one of these x values isn't going to actually be a true solution. So let's just double check. We've got ln of negative 5 plus 3 plus ln of negative 5. That doesn't work because the argument on both of these would be negative, so that's not a true solution. Let's try the other one. Ln of 2 plus 3 plus ln of 2 is supposed to be equal to ln of 10, and then we would get ln of 5 plus ln of 2. And then using that power property, we would get 5 times 2, that would be 10. So ln of 10 is equal to ln of 10. So that one does check out. So we do have one solution here, x equals 2. Now on this, it's going to be a different process, because notice that 3 is not part of a logarithm. So that's just a constant. If you have a constant term, what we're going to do here is collect all the logarithms on one side of the equation, and then we're going to rewrite it in terms of an exponential, and then we can solve for x. Okay, so let's get started. I'm going to collect all my numbers on one side of the equation, and then all my logarithms on the other side of the equation. And so we've got log base 4 of x plus 3, and that's equal to 3. And then I'm going to go ahead and just subtract this big term, which is log base 4 of x plus 3, just subtract that out and subtract it here as well. Okay, so then I would get log base 4 of x squared minus 9 minus log base 4 of x plus 3, and that's equal to 3. And then I can use my properties of logs. I've got subtraction here, so I can rewrite that with division inside the argument. So x squared minus 9 over x plus 3. And this looks like I could simplify it a little bit, because x squared minus 9, that could factor. And then my x plus 3's would simplify, so that's still log base 4 of all this stuff. Okay, so move up here. We would get log base 4 of x minus 3 is equal to 3. And now we're ready to rewrite this in terms of its exponential form. So I have a base of 4. So I would get 4 to the power of 3, there's the exponent, is equal to that argument. So that's equal to x minus 3. And then we can solve. 4 cubed is 64. And then just adding 3 to both sides, we would get x equals 67. And then when we go to check, it does work out because we've got log base 4 of 67 minus 3, and that's supposed to equal to 3, which it does because log base 4 of 64 is indeed 3. Okay, so that is a true solution there. Good. Excellent. Okay, so done and done. So your big thing here with logarithms is you're looking to see, is there a constant term? If there is, then we're going to rewrite in terms of exponents, and if everything's logarithms, then we're going to use the equivalence property.